Resume recording. All right. So the question was for homework 3, part 2, the ID setup for the local server. Do you need to submit anything? No, because it's preparing you for how to test your code later on in the term, rather than it's worth so many points. It's for, hey, here's some free points because you need to do this anyways. You might as well get some experience now earlier in the term, and some explicit instructions. All right, but here is what we're looking at so far. Well, this is, I wanted to check how things were going first. So we did something on Tableau already. I'm hoping Tableau went well. If it didn't, I would like to know. Rami's also more of an expert on Tableau than I am. He's actually done a bunch of projects on Tableau. So one of your TAs has experience with this if you hit any kind of problems. But I'm hoping in the past it's been fairly self-sufficient. How about marks and channels? Live factor. Live factor is not, we talked about live factor a fair bit last time. It's not 100% cut and dry, as in there's only one way to do live factor. Their live factor is, it's how much this graphic is lying to you. Is it lying at all? Is it underrepresenting? Is it overrepresenting? And as a result, the live factor is also open to interpretation. There's techniques to do it, and you're supposed to justify what technique what approach you take, but it's not just one size fits all. It's not like there's one objective answer for that thing. It's the act of doing it. Has any, I'm assuming homework 4 is where we start talking with D3, but I'm not 100% sure on this one. So has anyone had a chance to look at D3 or Vega Lite? Not yet. Okay. Well, we're going to find out the hard way. So next week, we're going to deep dive into some D3, and then you're going to go, oh my God, why are we doing this? And I'm going to say, we don't need to do it anymore. And you'll go, oh, thank goodness. D3, it's actually very, very powerful. It's extraordinarily powerful. That's why it was industry standard for so long. People are sort of moving away from it because they started realizing they don't need um, some magic language that does everything for everybody. If something like Tableau does the job 99% of the time, you don't need to hire a programmer to do Tableau. You can just get somebody that does a data analyst in there. But D3 allows you to make pretty much any kind of visualization you want on the web and just have it as a website. You can embed it in things. It's kind of crazy. Um, it's wonderfully powerful, but it's also can be difficult for new beginners, even after almost a decade of it being around. And we're going to look at Vega Lite, which is their build on that. So they made Vega, which is a way of tagging up D3, and then made Vega Lite, which is just, I'm going to give you the rough description of what this thing is supposed to look like. It's supposed to be this kind of graph with this kind of thing. Okay, now when you put the data in, make it look the way I told you to. It's a description of what the visualization is as an XML document, and that will actually generate the visualization for you. So that's what I'm going to be suggesting for your final projects. But let's see other kind of stuff. I'm going to grab some interviews at random in a second because I have them up here. Uh, does anyone have any questions or thoughts so far? I mean, how did it feel for you? Was it just awkward? Which for most people it is. Was it was it enlightening in any way, shape, or form? Was it a waste of your time? Oh, refresher. Where did you do interviews before? Steven, sorry, I should say the names. It was a good refresher, was the comment, in case you're not seeing this in the original chat.
Yeah, so can you hear me?
Yep.
So I did an interview before in uh it was another data, I think my previous like data visualization class. It was the one that we used data wrapper.
Okay.
Our professor had us do uh or actually sorry, I'm getting my courses mixed up. it
I get
was
them.
from a course last semester that I don't remember which one exactly off the top of my head, but yes, we had to do basically an interview of someone else. We had to come up with questions that were open ended and not, yes or no questions. And so this was sort of a refresher for me,
Okay.
which was good.
It might be good, but I keep on thinking you guys don't have any experience in certain things, and they keep changing the programs from before me. So, like, okay, you've done Tableau. No, we did Data Wrapper. Oh, oops. Yeah, moving targets. Uh, I'm gonna throw in Tori's because Tori, you didn't write your name on your thing, so I grabbed it without looking at the name. Yeah, writing for media. So I have to talk to who's teaching writing for media, by the way. Anyone want to throw that out there? Oh, Katie. Okay. Um, does she also teach the Viz class? I thought she taught okay. So she's all over in that area. And she's also, oh, you guys are all Carlton. You don't get to go to Algonquin like the other programs do. Oh, this isn't Tori's. This is Yushin, who's, and okay. So this would be an example of they didn't get to dive fully into it. Oh, this is an interesting visualization. But the question is, what could, so the interviewee, so what could we do here? So the interviewee is playing Switch games with friends, has plants flowers, and collects Legos. Great, very would fit right into my house. And I'm looking over all of these things and like, when are you buying Legos? Okay, at what times? How often do you have to look at your plants? And then we get into things like, what's the average cost that you're spending on Legos and planting in a month? Great. And that's something you could actually just visualize as a bar chart. The question is there something we could do with that data to help that, you know, to help the user in this case? So when I'm talking about budgetary money for buying Legos or finding Legos, right? Legos are actually a limited commodity. There are certain rare things that come up. Maybe that's something to look into. Maybe how many of the plants die versus don't die versus how much are you spending on your plants versus, maybe a budgetary app to help people, someone track the amount of money that they're spending. Um, so $72 a month, $288 in October. Okay, for a mobile game. Now, I'm cheap, so that's a lot of money to me. But I can afford it, but at the same time, holy cow, right? That's something maybe to monitor. What games are you playing? How often are you playing the games? Do you make your money's worth when you buy a game? You spent this much money on a game, and then how often do you play it? And mapping or correlating the amount of money you spend and the amount of time spent on a game to see if it's worth the money that you're putting into a game, right? How often you're buying Legos versus how long you keep them for and how big, how much room you need, that sort of thing. It scratched the surface. It didn't deep dive into what the use case was. It's a great start and it's a short time period. So that's part of the problem. But you could try and deep dig into how you could try and help the user once you know their task. In this case, buying Legos, planting flowers, playing, and I would dig into one of those three unless you really want to make sure you had all three, and playing video games with friends. How often do you play video games with friends? By the way, I play 2 hours of games almost every day. Boo. You should be spending that 2 hours on my course every day. I'm joking, of course. Okay, let's see. Here, I'm going to throw in this one here. I really need a better PDF viewer for my drive, or at least to have a new, better default one. Okay, so who is being interviewed in this case? Okay, Conley. What so what TV series is it, Conley? If sorry if I'm pronouncing your name wrong, but phonetic spelling for dumb professors, I guess. The other members of the group can also speak up just in case. That's a rookie number. You got to bump that up. Sorry, I just got that, Andy. Very nice. Um, oh, okay. That's Kara. Because there's something about a butterfly effect where you get a change course over time. I think life can be. Yep. But that, although that's a movie with Ashton Kutcher. Um, every day, 2 3 hours a day. I'm sorry, guys. I'm, I'm like I splurged. I watched a half hour of TV. Um, now it's next season to total. Okay, how to keep track of the characters by seeing the names repeated. Okay. Um, so what were you hoping to get? They're trying to achieve normalize. Someone tried to kill, and that things changed. Okay. Hard to predict what would happen. Oh, that's actually really interesting that you could do. And a character web. There you go. That's what I would have thought too. You have a time, you have time, you have character relations, you have cause and effect things that you have to keep track of for a convoluted storyline like this. So now, once I get that information about the TV show and the problems with the TV show, which is like that it's a convoluted TV show where things change when one thing happens, everything propagates outwards. Now my question is, can we produce something that lets people keep track of and piece together how all of these things are? You could do the same thing for Donnie Darko, in case you're wondering, or maybe you didn't watch Donnie Darko, whatever the new movie that confuses everyone is. Um, right? It's that the and now you need causality, you need time, you need different, I guess, another dimensionality of when something happens, how many other cause and effects, or maybe you can repeat or play through the cause and effect to help people track what's happening in the show. Great. That's something that would be useful if you're a hardcore fan. You're putting in that. If you don't believe me, watch any science fiction show, almost any other science fiction show, and see what they have produced. I have a Farscape cookbook downstairs, right? That's science fiction TV show that people like to cook. They made cooking recipes for a TV show. Uh, Character web for something like Game of Thrones. How many people died when they died when they got killed? Yeah, Game of Thrones is wonderful for that. The sheer amount of intrigue. Now you don't have cause and effect. You have cause and effect, but you don't have this weird going back in time causing a ripple effect afterwards. Slightly different, but yeah, we have a lot. We have this social network, if you will, of everyone. You also have geographic that you have to map onto this thing, and you can see supposedly there are certain events in Game of Thrones where suddenly the timeline of a lot of people suddenly stops. Uh, there's a lot of death in that show. So nice. Yeah, that's exactly. And you could dive into that, right? So your job is to figure out what they're doing and then realize what's special. And that's hard. And then sort of expand on that. Nice. Okay, let's see. I'm just getting people that don't properly name their files. Sorry, but it's I need to choose somehow. I figure that would be as good of a choice anyway. I'll do one more and then we'll see. But so far, I mean, this is the kind of thing that I was thrilled that you guys got to do it. I'm thrilled at what I saw. That would explain why they're actually better than what I would normally see because you've done this before in another class. It is the bread and butter of what we do. And so I did interviews for the end of my PhD for 35 different people at an hour a piece or something like that. I can't even remember anymore. You hear a lot, like you get, and even then that's minuscule compared to a lot of ethnographers. But you get really good at that sort of improvisational task. You have a rough outline, what you want to talk about, especially you guys for later on today. Rough outline of what you want to talk about, but you don't stick to the script. You got to sort of let it teeter and veer because there's nothing worse. I don't know if you've ever heard like a talk show host or a podcast. I'm listening to Smartless, Jason Bateman, Sean Hayes, and oh my God, Will Arnett doing just sort of a stupid podcast, but interesting, fun just the same. And Will Arnett just asked this question, like the person answered the question, was answering the question. They're starting to have a conversation, and then Will Arnett throws a question that was completely torpedoed, like out to left field kind of question, and just you could feel it ruin the interview, right? You don't want that. This is just one example, but that's what we're trying to avoid. Okay, what are the main topics Reading, 20 minutes to read. Okay. Boring. Research. Okay. What kind of books you read? Novels, literature, and education. Okay. All kind of genres, fiction and nonfiction, countries, touring. Okay. So all over the map. Who's interviewee? Okay. Xinping. Um, how many hours do you spend? 3 to 4 hours per day, 3 to 4 hours a day. Finish the book, takes a break, and starts a new book. Wow. First of all, you guys can read. Congratulations. It's better than me. I don't like reading. Um, although I hear we have a textbook that you can read as well. Nonfiction. You enjoy, dislikes textbooks? Oh, come on. Just answer my question here. Find them hard to understand. Yes. One of my personal favorite lines when talking to my math friends was I go, how do you read like a math, when you read a math research paper, like, do you understand it right away? And they go, no, you got to read it like 4 times. And everyone thinks you should be able to read a textbook and understand it. And the reason they do math is because they're the few people that read a textbook and go, I'm not expecting to understand it right away. I need to read it 3 to 4 times. Uh, just a perspective change, in case you're wondering. Same with programming. Okay, on average, how long books you read, fans, books. Okay, so the question is, now that we've got a bunch of information about the books being read, what would be useful? Do we want to track how many books are being read, how long the books are read, how many pages are being read the run of a year to figure out if they're wasting a lot of time compared to doing their academic work, if people are overwhelmed with their academic work? Do we want to figure out how much money is spent on the books? Do we want to figure out, right? Um, The Godfather is interesting, yep. Although the author of The Godfather is a bit of an arrogant ass from what everything I've read of him. Some of the thoughts of the character in more depth. Okay. Okay. But we haven't gotten into why or what we could do to help. This is what is the hobby? This gives us the groundwork. This is a great first step. And now we need to start drilling into, besides just The Godfather or something like this, what ideally, where are you confused by the books you're reading? Or where do you wish you had some extra kind of support? Or what kind of things confuse you about the books you're reading? Like how much time you're spending, are you concerned about plot lines? You're on the lookout while you're doing this. You have multiple things in multiple fires here. You're trying to also figure out how you can help the person by understanding their domain, but you're on the lookout for something weird that's happening. So, for example, that's a lot of reading, at least from my standards. 3 to 4 hours per day reading is an incredible amount of reading. I know people that have read more. I know people that read at least a novel a day. They walk while reading and they blow through a novel while walking places. But do we need to keep track of that? Because they don't probably remember all the novels that they've read over the years, right? Do they want some kind of thing to find the next novel for them to read? That would be, how do you find a novel, right? You found it from the Godfather, but what other ways do you find novels to read? That's the kind of thing we're looking for. You're trying to get the overview, but then you also need to always be on the lookout for where this could be useful, where the problem is, and how you can help with the domain. Nice so far, guys. Very nice. All right. All right. Uh, so it's great that you've actually seen this before, that you're a bit more comfortable with it. Normally, people are really awkward when it comes to interviews. I want to also hit one other thing before we move on to, you know, half hour in, what we're actually going to be doing today. So I want to talk about the token policy, and not Tolkien. I always want to put an I in there, and an L, I guess. But the token policy that we have here is, I played a little bit fast and loose, but let me try and explain what's going on here. The plan of attack right now, at least, is where you get 2 tokens during the turn. Tokens to use whatever way you want. If you have a late assignment, other than the Dear Data 6 and 8 would be I think it might be 5 and 7. Actually, I might have to change that. The Dear Data where you're actually producing the visualization that somebody else has to review, because it's contingent on somebody else. I don't want you being late on that one. But if you're late for an assignment, you can use a token. Otherwise, you get 0, but you use your token. Hey, you're not late anymore. It gives you 2 mulligans, if you will, like what we had in 1400 for anyone that took 1400 with me. If you missed a class and you missed an in-class activity, use a half a token, right? So you can miss 4 class activities for that. Maybe you drop an assignment, right? Maybe we count that as 2 tokens. Uh, And what about late submissions for a group? I don't like this idea, but on the off chance that it happens, if a group is really late and, for one of their submissions, maybe every single person in the group has to use 2 tokens or something like that. That's an emergency, like, don't do this, but in case you have to, you can do this. The reason I want this is just because I'm really opposed to the person that's the best at schmoozing getting ahead. I'm actually good at schmoozing with my professors back in the day. So this is not because of I was burned in the past. It's just because I know there's some quite people in this class that probably are not the best at schmoozing or are embarrassed to ask for, either an extension or they get overwhelmed with schoolwork, right? If you're overwhelmed, take a token. If you can't get the assignment done on time, take a token, right? That's what they're there for. They're allowing you to be flexible with what's going on in your life. So if you miss an in-class activity, don't panic. Tokens cover it. Now, I might add a third token. Depends on how people are doing. The issue I have had in the past, or at least last term, was despite saying how much of an ogre I was, despite saying how mean I was with the grading and stuff like that, I couldn't lower down the grades to enough. There was first of all, I was very proud of the grades I was giving up for the 2100 last winter because people did phenomenal. There's like 3 or 4 groups that did phenomenal final projects, and there's no way I was not giving them an A. Like, holy crap, final projects. And then there was some that gave me garbage. I mean, not garbage, but not at that phenomenal level. But still, that meant there was a whole lot of people in the A range, and they were, hey, too many A's. Uh, so I don't want to give out too many tokens because it's going to make the matter worse. If you guys if you bring your A game, like like last term, the students from last term, I'm going to have too many A's, and I don't want to be giving out even more A's because I gave all these extra gimme tokens, right? So we'll have to play it by ear. I don't want to be. I'm not also failing the class either. So it depends on how things are going. The tokens are there to take the stress away. Okay, so if you're panicked, ask about the tokens. That's fine. We will just set them up at the end of term. Not now. Don't have to pre-plan when you're going to take, a week off or something like that. It's end of term. Oh, I missed an assignment. I better use the tokens on that instead of the missed classes. Right? It allows you to adjust at the time, and we'll just sort it all out at the end of term. But just letting you know, it's not um, our late policies are not to try and traumatize anyone. That's why we have the tokens. Okay, quick. We were doing hurricane editions in the previous terms. Then I started picking up COVID-19, so I left the hurricane edition ones of these. But I just like pointing out some of these things in case you're wondering. Just other samples of visualizations that have come along. So I actually love this to the point that I got the New York Times just so I could do this. There we go. I'm going to move it over now. I love this visualization. It actually came up in my first time I taught this Viz class simply because they had the same kind of idea. They were talking about, showing things over time, and they're trying to convey or communicate a message. The New York Times visualization here does a beautiful job at this. Here we go. Hopefully I can do it properly. So we talk about Hurricane Irma, was one of the strongest storms in history. So you get a clear sense of where Irma is. And here are the other hurricanes that most people remember at that time, at least. This is from 2017. And as you scale down, you start seeing other text that you can follow along, mapping up to other visualizations that are all interactive that you can go over. But notice the text and the visualization correspond, but there are a whole bunch of visualizations. It's telling a story linearly, top to bottom, with visualizations in there so you can explore, but it's still guided, which is one of the, when you're talking about communication as the task, you're communicating how bad Irma was compared to other hurricanes. That's how you do it. You're not exploring hurricanes. The journalist has already done it. They've already pointed out how bad Irma is compared to other hurricanes. They're trying to communicate how bad Irma is to compared to other hurricanes. So here are the set of category five. Here's the category fives, right? Isabel from 2003, Hugo from 1989, David from 1979. Oh, 3 years after my birth. Okay. Alan from 1980, right? Here are the massive hurricanes. Here's a whole bunch of hurricanes down here, and you can just explore. As you go down, Irma's classified as category five, telling part of the story, how it changed over time. Here, Irma has been broken records for accumulating cyclone energy, right? There we go. As we keep scaling down. Oh, and then that's the end of it, that particular visualization. But notice it's interactive and it transitions from one to the other. It's really, I thought it was really quite nice. So that I would say would be fame. Okay. This, on the other hand, I'm not so sure about. You can hopefully get it. There you go. So that's her category one. Let's see what your opinion on this is. It's category two hurricane. Hopefully you can see it. Category three. Here's category four. It's disintegrating the house. And category five is a nuclear explosion, it seems. Okay, so my question to you, I'll leave it on, but hopefully it's not too distracting. What are your thoughts on this? Is it a shame or fame? What do you like and what do you not like about it? I'm going to have some coffee while waiting for you guys. What's bad about it? Hmm. I would agree with you. You can't manually control it, so I have to shame. It makes you want to perform a life factor. Beautiful. Well, life factor in the actual license, not necessarily in the tufty, like I'm measuring exact things. 3D, it's an actual physical thing, so 3D is fine. If it's abstract data, 3D, you got to justify it. Very continuing, I got to. And what's the house made of? It is the crappiest house ever. I think there's some little pigs that are running out of it afterwards, so that's nice. But there are so many variables in the structure of the building. Skeptical about the accuracy. I got one other little gotcha in there, but I think it's actually been touched on by a bunch of people already. It's continuous, right? So when the roof starts get peeling off in category two, you're not starting fresh when you get to category five. So it's a fame and a shame. I don't know how to categorize it myself because you're absolutely right. It tells you the wind speed, it tells you the effect of the hurricane, tells you how powerful a hurricane is, makes you question the building materials used in this for this particular house because I wouldn't want to live in a house that made whatever that is in Newfoundland even. Right? It's there's should be able to handle a bit more than a category one. Um, Hard to tell the boundary between, although the boundaries are they're um, they're not hard barriers for boundaries for a hurricane. But I would actually have liked to reset the house for each category because the problem is it's half disintegrated by the time the next hurricane thing kicks in. Although it's more realistic to how a hurricane would actually hit that house, right? It might ramp up or start and get worse and worse and worse. But yeah, the boundaries between categories hard to see, and the fact that you're not starting, but it's all weather forecasts are all about doom and gloom. The American Weather Channel stuff, they're always like, and now I'm in a simulation of a hurricane, or they're going out into hurricanes to get blown down the street. They really like that kind of. it's I guess clickbait or ratings boom. But yes, you're right, it is doomy, right? Because I don't get to reset it each time, and because I have no control over where that thing is animating, I get the I sort of get the gut reaction, I get the visceral reaction, but I don't get control to explore. And so I think it's a fame and a shame, if you will. I think it's both. Right. All right. So we're going to learn about data sets today. Data types, data sets. And we're going to learn about what kind of different kind of attributes we have. You will see me. This is my what I beat to death for people. It's one of my little like, isn't this cool? Uh, and we're going to talk about picking the appropriate visual representation, including what we were talking about there, and why we'd use a line for hurricane visualizations. Right? Why we use one thing over another. Why am I not using rainbow color maps everywhere? I maybe it's over, oh, it's like the Matrix. No, but it's good. Hopefully, it changes your mind about things. Change your mind how you look at the world. It's not as radical as leaving the Matrix, but it is hopefully something that changes your perspective on what you see around you. And it will drive you mad every single time someone presents data the wrong way. You're like, that's categorical data, you bastard. No, you should get upset when people do it the wrong way, or at least I get upset. So, what kind of data do we have? Maybe you've seen this before. I'm hoping you haven't, and because otherwise it's going to be a real boring lecture. But that's my wife back there. Uh, what kind of data? Like, if you're talking about types of data, generic as you can. What types of data are there? And I'll wait. Just throw it in the chat. Hurricane data. No. Oh, quantitative versus qualitative. Very scientific. Images, categorical, quantitative kind of thing. String flow chart. Nice. That's a very. I taught you 1400. Integers and strings. That's a program. That's the programmers in us here. Numeric text. Yep. Date. Yep. Time. Shape. These are all great. Ordinal, nominal. You're cheating, Kara. That's where I'm going to be going. One of the things I'm going to be going to. But all of these are also fine, including the images thing ends up being, I don't know how I want to parse this. And that actually breaks down a lot of the ways we look at data. You actually have to categorize something, or you have to break down the image in order to fit it into these categories. So it's sort of shoehorning the data. Numeric data, what defines numeric data? What defines text? What is text data? And how do I use it? So in case you're wondering, when you deal with text data, you will you'll learn to hate it, right? Because it leads to all sorts of weird quirks. So the date, you can consider that numeric data. It is actually continuous numeric data. It's actually continuous data if you have that level of granularity. But if you clip it at like days, then we suddenly have integral data. We have um, it's still continuous though. Yeah, structured, unstructured. We're going to get through that with data sets. Nice. So we have to break it down in a whole bunch of different ways. One of them being depending on the attribute of the data itself. And then we're going to have data sets and what the different data sets are. And then we can look at it in terms of a dimension of like we're looking at text. I have a friend that's actually an expert in text analysis and visualizations. I think he's UOIT right now. Fellow Newfoundlander as well. So I don't know how many Newfoundlanders got a PhD, but anyways, he's way better than me. But he does text analysis for visualizations, and there's this whole other field for that. It's great data, nice, and yes, it's discretized data. That's the word I should have been looking for. Thank you, Kara, for If you're talking about a calendar date and it stops on a date, it actually becomes discretized. It's discrete. It fits into these boxes, but not, there's no like part way. You get a 1 or a 2, like the integers, not 1.5. The discrete data, it fits in you, it's not continuous all the way across. And we'll look at that as an attribute. So when we talk about type of data, I'm talking it's either structural or mathematical interpretation of the data. So you can describe the image, you can mathematically break it down. A sound wave can be mathematically broken down into a whole bunch of sine waves. Any sound, I said sound, right? Sounds can be broken down into sine waves. It's actually called Fourier transform or fast Fourier transform to do it quickly. Right? Well, almost anything you deal with, if you're talking about faces, and I throw a bunch of faces into my Google Photos, you can break down that image and the person's face into a series of different measurements, and that defines or identifies the individual person. Everything you can throw at this stuff, you can try and categorize or you can try and quantify. So the data types we're going to be dealing with, we have items. That's normally our rows, our nodes. It's the individual item that we're dealing with. We have attributes associated with their data. So the item is, me as a person on LinkedIn. The attribute might be schools I go to, the number of connections I have, that sort of thing. The variable, the dimension of data. We have links, who I am connected to. You could say that's an attribute, but if I'm showing all these connections between people, the connection is mutual. I want to identify that differently. Links between my data, relationships between data. Positions would be spatial positions, locations in space, where I have lived. Right? I am the item. I have attributes like how to the degrees I have, or eye color, let's say. I have links who I've connected to, positions where I have lived in space, and grids is something a bit weird, and that's when we get to more scientific data sets, where I get if it's purely continuous and I don't know what I'm like, just this open-ended space, like an image, let's say. How do I analyze it? Maybe what I need to do is discretize the space, break that space down into little chunks, and then sample within these discrete spaces. Or maybe I just randomly sample and then discretize later. We'll get to sampling and discretization in a second. But here is a visual representation of it, right? If I have a table, I can have a multidimensional table. This is, by the way, data sets, right? If I take my data and take a step back and look at the data, it describes a data set. It's a collection of information that it's the target of my analysis. So it could be a table, so it have a bunch of attributes, and each row, like a database, each row is an entry, a person, let's say. It could be, or a type of data. So every single one of my courses, I have you guys as the rows and your grades in the course as columns. The columns are attributes, the rows are the person. I have multi-dimensional tables. So all of my all of my students for my courses and then the attributes, right? It becomes three-dimensional or four-dimensional space. There's no upper limit to the dimensionality of those tables, but two-dimensional is normally what we think of. A network is who I am, information about me, and who I'm connected to. But the important part is who I'm connected to. Game of Thrones, right? Who is connected to who? Who killed who? Who had, who had sex with who? Like that's Game of Thrones is all about scandalous things. I have not watched it. I will say that. I just know enough. I know enough to be dangerous about Game of Thrones. I should watch it, but it's really I don't want to be that depressed. It's gonna make me really sad. I like happy sunny sci-fi. I like Tolkien. Um, right? A tree is a kind of a network. It's a hierarchical network, but it's a kind of network. Yields, on the other hand, I was like, what the hell is this? A House of Commons? What is a parliament? Is it the UN? What is this thing? When I first looked at this, a field is just a general open space that I'm going to discretize into these little cells, and then I'm going to measure things about the cells. We'll see some examples of that soon enough. But it's not this person, this attribute. It's this image. What are the kinds of colors in this image? I can measure each one of the things, or I can randomly sample. And then geometry, which is what everyone seems to go for with this class, but it's hard to do. It's harder than you might think. Where we have a geographic mapping, we have a physical mapping in the real world, or some kind of like it's a car, or it's a map of the world, or it's a map of the city, or it's a floor plan of my house. So it could be anything, just spatially oriented. Brain scan, and I can map things on top of that. But it's constrained to a geography, if you will, or geometry that you're dealing with. Here's where the sort of I'm hoping once we get into this, here's where I'm hoping the big thing is, the big aha moment is. Notice what we have here for each of these. A table, I have items and attributes. A network, I have items, links, and attributes. Fields, I have grids, position, attributes. Geometry, I have items, positions. Technically, I can throw in attributes. At those items, positions, I can add additional attributes. Clusters and sets, I don't really have attributes. Oh, but I could include them. In fact, attributes keep on popping up every which way. Oh, I think I'm doing geometry, fields next. But the preamble here is attributes keep popping up, and how I look at attributes also changes how I visualize stuff. Okay, let's do the continuous fields first, though, just in case to clarify things a little bit. And we have a nice little pop-up thing here. We're going to have it's actually relevant to anyone. It's how you look at the world, personal viewpoint, I guess. Right? If I'm in a scientific field, though, it becomes critically important because if I'm dealing with a physics simulation, if I'm dealing with a chemical reaction, if I'm dealing with a biological system, and I want to see how genetic diversity changes over time, I cannot sample every single person, every single red-winged blackbird, right? I can sample a subset, and now it matters where I get those birds from. Where are they being picked up from? Where am I getting the DNA sample from? If I'm talking about psych experiments, it's the same thing. I'm not taking blood samples, at least I hope I'm not for psych experiments, but I'm pulling people into the lab and I'm seeing what they like about my system. How do I choose those people? I can only sample a subset of the population. And how I choose that subset of the population tells me if I can actually generalize the data or not. Sampling, figuring out that grid is critically important for pretty much anything. If I cannot measure every single thing on the planet, I can only measure a subset. And how I choose that subset changes my data. This is where you should, just yell at people when they do things wrong. They do science wrong. Because if I don't sample correctly, then I don't know how to interpret the results. So here are the different things we could do for our grids. We can take a uniform grid, as in I will ask every 15th house if they have COVID or they've gotten COVID. It's a random, regular interval, right? I'm going to go to each neighborhood and talk to one person in one house for every single street in Ottawa to find out if they've had someone die from COVID. It's a random sample, or it's a grid. It's regularly it's uniform sample. But by choosing it on a regular basis, you can say it's random. Not really though. How do you choose that one house, right? If it's the first house on the street, that's going to be different because the house further down the street might be different. Okay, that's uniform. Rectilinear. Okay, so let's say I do that sort of thing, but there's certain areas like Alta Vista that have more COVID than others. So in places where I have more COVID, I test more houses, still at a regular interval, but now it's 2 on a street or 3 on a street. Rectilinear is I'm going to do a grid pattern, but I'm going to put extra fidelity in certain areas. Structured, I have some kind of algorithm determining how I am choosing the houses that I'm going to be sampling in my neighborhood, right? There is a rhyme and a reason. It may not look like it might look distorted, but I'm choosing it based on a particular algorithm so I can reproduce it later. And then I have unstructured, just get some stuff, right? Maybe so the grid, the areas what I'm checking out, instead of it being areas in Ottawa or particular or uniform, it actually shouldn't even be areas in Ottawa. It should be like this block of geographic land in Ottawa, I'm going to measure. This block of geographic land in Ottawa, I'm going to measure. Unstructured, it could be uh, city boundaries work fairly. City boundaries can have a structure to them. You know what the scaffolding is. This thing is, I'm going to choose some random subset. Now I can still reproduce this grid or this structure, but it doesn't have a really clear rhyme or reason. You can reproduce it, but it comes up in weird ways. So let's give an example. So if, by the way, if in case you're wondering where this comes up, I think I have a later thing on uh, yeah, I think I have a later thing on filtering and aggregation when we're talking about um, what the heck's a gerrymandering in the United States, where you choose where people are in different areas or who their representative in the House is, where how many people are going to Congress for the Democrats versus Republicans, and it becomes this art form for how you draw the geographic boundaries to pack people in so that they get only one representative from the other team, and then you get three representatives for your team. Right? How you draw the boundaries changes how the data is represented or what the data is. So here is, I have a whole bunch of data points. I measure, 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 measure. Maybe I'm just taking measurements of the color in an image. And I'm going to say, what do I expect the value in this at this position here to be? So maybe I'm testing wind speed at various things. Maybe I'm testing temperature. I can't test all the temperatures for the entire area. I have to test various samples within this on the surface of this metal plate. Or maybe it's COVID cases in this area. If I'm going to say, what do you think the chances of this person having COVID? Or what do you think the chances of the temperature right at this point? What do I expect the temperature at this point to be? Without having measured it, what do I do? It depends on how my sampling works. So if I say the grid looks like this, with this, as I have a triangle mesh around this thing, I would expect it to be one value, right? Depending on these 3 points. If I have a quadrilateral mesh like this, the value is going to be different. It's going to be based on these 4 points, not just these 3 points. And my interpretation of the results, my interpolation, is going to be different. In case you're wondering how this comes up for metered production, uh, what do you think a triangle mesh is? Like every single computer graphic, normally unless you're doing ray tracing, it's a whole bunch of different triangles, all stitched together. And the color of the triangle, what is it? It's based on the 3 points that make up that triangle, and you color that triangle based off of those 3 points, or the face represented by those 3 points, the plane or region represented by those 3 points. That's what a triangle mesh is. It's an interpolation, and how small you can make those triangles makes you a better looking image in 3D, in a 3D mesh, in a 3D scene. That's what we do for graphics as well. It just pops up in weird ways. We have this open-ended space and we discretize it. We choose where the grid is, and how you choose the grid changes what values you have. In case you're wondering where this comes up, hopefully I have an example of it. Oh, here's a Voronoi tessellation. So we have a bunch of random points. We plop it down onto a grid. So we've taken a bunch of samples. One way of doing it is called a Voronoi tessellation. I'm not asking you how to do a Voronoi diagram. This is what it looks like. It is a geographic region that is the minimum distance between this point and other points. So between this point and this point, the line that separates the two is here because it's halfway between these 2 points. It's halfway between these 2 points. Halfway between these 2 points. If I just throw a whole bunch of, like, just say I throw a whole bunch of little dots onto a map and draw a grid, I get a Voronoi tessellation. you can actually look up the way of doing a Voronoi tessellation. And where it's useful is like, okay, if I'm taking samples for galaxy evolution, for example, what does it look like? Well, the regions and how I'm calling the regions are based off of all the samples I take and my Voronoi tessellation underneath it. By the foot? Oh, yeah. That's what it looks like that. Nice. Or k-means clustering, right? I have a whole bunch of data points. How do I choose the clusters that these work together? That's a grid. I'm choosing the grid based on the data set coming in. I have a bunch of data. I define the grid based on the data. And every time I have new data points that are supposed to go in there, I figure out which group or cluster they go into based off of this. It gets very mathy. But the point I want you to walk away with is that mathiness tells you how to interpret the data. And if you don't interpret the data right, the numbers you get are gibberish. Okay, here's one other one from where what I used to do. So this is a helicopter. This is a helicopter blade. You're actually seeing wind resistance on a helicopter blade, and they're using a polyhedral mesh, as in they are determining the airspace and what the geometry of this helicopter based on a polyhedra. So instead of just triangles, it's three-dimensional, and they're trying to run a physics simulation. So what they do is they figure out this polyhedral area, and they figure out what the physics in this area is, what the physics in this area is. They discretize what is continuous space to do on a physics simulation. That's actually what they do in industry. And notice what happens out here where I don't expect much change, or I expect very simple simulation, big grid. And when I get around the actual rotating blade of the helicopter, look how fine grained that those polyhedra meshes are. They become ridiculously small. It's not a uniform grid. It's not rectilinear either, but it is, I'm increasing the fidelity at areas where I expect the physics simulation to be crazy. And that will give me a better simulation of how this airplane wing will actually work. This is actually from my work from way back in 2011. But this is what they do for physics simulations. They will discretize the entire space programmatically, and then you'll increase the fidelity at certain areas where you think the physics simulation are going to get a little crazy, and that's how you run a simulation. Okay, so we've looked at all these things, and then we said, hey, all of these things have attributes. In fact, I'll throw attributes into geometry and clusters and sets. In terms of a set, it's just a bag full of stuff, bag full of items. It's less structured than the other stuff, but we still have attributes. No, we do. Okay, we still have attributes, and that is where this is where the eye-opening experience for me was. Maybe it's not for you, but hopefully it is. Because the attributes, how you use the attributes, changes how you represent the data, and that's actually one of our big go-tos when it comes to how you visualize something. By the way, the data sets also tell you how to visualize something. So 3D is allowed right here. If you have geometry, go ahead and use 3D. If you don't have geometry, maybe fields as well. If it's a geometric based, you're doing a bunch of fields in a geometry. But if you're network trees or tables, yeah, don't use 3D. The general rule, right? Attributes tell you another thing. It's how you actually represent the data itself. So we have categorical data, things like types of fruit, colleges you go to, um, countries on a map. Those are categorical data. They are not the same as other types of data. There is no ordering effect whatsoever. Is a square better than a circle? Well, some people might, some of you might get into, I'm going to start a war here. It's like, circles are better than squares. You know, they're just different shapes, right? They're not better. You could try and order it by the number of points this thing has. Then it would be like 0, 3, 4, God knows how many, right? Right? They're just different shapes. If I have countries, you're not supposed to rank them in terms of some are better than others. Some people might disagree with that, right? They're just countries. That's why maps look the way that they do. They're those different hue-based colors because there's, Russia versus Canada versus the United States versus Colombia, right? There's no rhyme or reason for what color you're going to choose. They're just colors. They're just countries. You just want different colors between the different countries, but you're not saying, well, Russia's better, so we're going to make it more bright. There's no ordering effect. That's the key with categorical data. Ordinal data or ordered data, there's an ordering you can choose, but the difference between the levels, and this is what confuses a lot of people, the difference or distance between these things is not uniform or you cannot infer anything. So technically, months, there's an ordering effect. You could say how many months are in between each of these things, but you can't say the number of days. Sort of, it's non-uniform. Um, so normally we consider months to be ordinal data. You could say consider dates to be technically ordinal data, unless you count the number of days in which you can break it into continuous data or integral data. But t-shirt sizes, coffee sizes are my favorite of all those, right? What is a venti? I don't know. How many ounces? I don't know. It's the big ass one. I don't know. Tall venti. Like, just, if you don't know what the size of this thing is, if you say I want a large coffee and you don't know where you're going, what are you getting? You're getting the coffee that's bigger than the medium. That's all you're getting. You don't know anything else. That's so every time you buy clothes online, let's say, how big is this? I don't know. It's big, large. I don't know. Depends on what store you're buying it from. If I'm buying running shoes, for example, depends. Technically, it's supposed to be measured by a certain amount, but not all shoes fit the same size, right? An 8 is bigger than is smaller than a 9, but yeah, t-shirts are a better example, right? If I buy a large shirt, sometimes it fits, sometimes it doesn't, or sometimes it's really baggy. And then we have continuous data. Now, I normally break it down one step further. I say continuous, like quantitative data. I say continuous versus integral data, where I have discrete chunks one after the other, but I don't have this infinite granularity. So length would be purely continuous. I can go 1.297329 versus number of people. I don't get 3.5 people. Well, that's really gross if you have a half a person, right? It's three, or you have four people. You don't have sort of half a person. The average might be 3.5, but the number of people in a room are three or four, but not 3.5. And so this would be quantitative data. When we measure things, we tend to like computer scientists, especially, like this. Qualitative, one of the examples like people gave me earlier, is not fitting into this nice little attribute category unless you can take the qualitative data and break it into these little chunks. So if I do an interview and they're talking to me about in this interview, I can do a word count on the number of times something came up. I can convert qualitative data to this kind of format. I can find out the most common words. I can find out, um, I can find the ordering based on the interview, but I have to parse and have to extract data from the qualitative data. Qualitative is just, it's, or text, right? If I'm parsing or interpreting text, if I'm going to get an attribute from it, I have to break it down. I have to take that open-ended text and convert it. I have to derive data. But at the end of the day, if I'm having data and I'm visualizing it, it's this. If I have a tag cloud, it's this. I can't visualize qualitative data. It's just a bunch of text. So, so I want to look at this a little bit. So I'm gonna leave it up here for you to look at. Here is what we have. We have an order ID. This is just a table of data. Do we have quantitative, ordinal, or categorical data for each of those rows? So for the order ID here, what kind of data is this? And you're going to let me close the door. What kind of data is the order ID in this case? It's a number. It's categorical, yeah. Why? Because there's not my first order versus the 17th order. You could say ordinal as in you say order number increases over time, but yeah, we're treating them as an ID. Your student ID is categorical, right? It identifies you, but it's not like this number is a better number for a student ID than another number. Great. What the order date? It's open to interpretation as well, but and then order priority. Let's do that one as well. Yeah, I'd say that's definitely ordinal, right? It's a priority, but a priority 5 versus a priority 4, I don't know. It's more urgent or less urgent, right? Under priority 5 is not that urgent. Priority 1 is urgent. How urgent? I don't know. I don't know the difference between a 1 and a 2. I know it's more urgent, but that's all I know. That's a big takeaway, for one of the big takeaways here. Product container. I'll do order date in a second because that's one of the always weird. You can interpret it a bunch of different ways. Well, small versus large, that reeks of ordinal. Small is smaller than a large, but how much smaller? I don't know. Product base margin, that looks like quantitative, right? It's a measurement that I could put in there. The shipping date, we have we have exact dates. I can convert it fairly easily to some kind of ordered group, and there is a discrete difference between one day and the next. It's a 24-hour period. I tend to like using dates as quantitative myself. But let's not find out. Yeah, hey, I said quantitative last time. I forgot what if it was going to be red or not, right? Because I can convert it down to single dates, and I know the difference between those dates. Heck, I could do the exact time if I had the time stamp in there. I could do the exact time. I could almost infinitely do that. But I would like to think of that as integral data. It's the difference between 1 and 2, not 1.5. Right? There's no 1.5. It's 1, 2, 3, 4. Whole numbers, if you will. But that's definitely ordinal data. And this is just categorical. Despite it being a number, it can still be categorical. There is no ordering at all between these things, other than maybe time when you got it. But if that's not important, it's categorical. And so it's, yes, it is up to interpretation, but that interpretation tells you how you want to represent it. And we'll see that in a second. So how about this one? We have a bunch of different things. We have ocean, ice melt, land, atmosphere. We have some dates on the bottom, and we have something on the y-axis, which is the amount of heat accumulation. What do you predominantly see here? Do we have categorical, ordinal, three types in one chart? So where are you seeing the other? So ordinal, where would you see for ordinal? I could see ordinal for sure, but where are you seeing the ordinal? Or categorical, depending on how you want it. The year. But the years are always the same distance in between. So in this case, I would actually say that maybe we're going to find something out different here, but the year's not going to really shift at all. The year difference between 1980 and 1981 is 1 year. So I would actually consider that uh, continuous personally, but again, open to interpretation, right? The year, each individual year, you could just it's a spectrum, it's a continuous thing. Uh, I would say we definitely have. I could call this. You could call this categorical. We could also call it ordinal. The difference between the ocean, the ice melt, the land, and the atmosphere, if they're stacked one on top of the other in terms of actually how they're actually positioned in space, you could tell them ordinal, but I would also probably just call them categorical. And then the number of the heat accumulation, that's definitely continuous. All right, let's see what we have here. Quantitative. Okay, that's fine. Continuous, quantitative. Quantitative as in you can measure it. Quantitative as in it, or continuous as well. I would say uh, integral, but that's continuous is I can get infinite things. That's it versus I have discrete data. Discrete is probably the better term than integral. Discrete data, but still quantitative. And oh, I didn't actually do this one here. I would call that categorical right now, at least, but you could call it ordinal. Why? Because it's always open to interpretation, but would you just continue on dates one after the other? That's one way of looking at it. How about this one? Mm, still one of my favorites. Actually, it depends on how you interpret this. The visualization itself, we have a bunch of categorical data, although he's implying it happens to be he, I know who makes the cartoon, but it happens to be categorical data that he's making a judgment call on in terms of difficulty to peel and eat and tastiness, but it is categorical data. Watermelons and pineapples, there's no really ordering effect of it, maybe alphabetical. Uh, but there's also this attribute that it's being interpreted as continuous, as quantitative data, but it could be discrete. It could could be discrete data. It could be ordinal data, but he's by using a scatter plot, he's implying that it's continuous data. Notice that the data itself tells you like the visual representation actually dictates how you interpret the data, how he's interpreting the data at least. He's actually saying ordinal, easy versus hard, but I don't think it's ordinal. I would actually consider this to be continuous the way he's represented it here. But it really is ordinal. You can't tell like really tasty versus sort of tasty. The data itself under the hood is probably ordinal. It's seeming to suggest that it's continuous because using a scatter plot. Tasty versus untasty also would be ordinal in the data, but it's being interpreted as continuous. And categorical. Fine. We're going to skip ahead on some of this, but what do we have here? Different airports? Categorical. Unless you look at it and go like LAX is a piece of garbage, in which case we have ordinal. But really, it's supposed to be categorical. The data for the actual airports themselves is categorical, but the amount of delays, cancellations, that sort of thing, that's continuous, quantitative. Actually, this would be discrete. You have only 20 delays versus 20.5 delays. So 20 delays, but it's still quantitative. Quantitative being the quantitative covers both continuous and discrete. I just always mix and match my words here. Quantitative means you can measure it, you can quantify it. And now this my question. Student evaluations are wrong. Why? They're really wrong. Like, and yet everybody does it. Every single school does it. Every professor complains about it. But when you do a student evaluation, when you guys evaluate me, for example, what do? You measure on a Likert scale, right? You measure how good is this professor on a scale of 1 to 5. How good is this professor? But let's just put the the things in place here. And I get my average student evaluation at the end. I'll also you also put like a little bar graphs and stuff like that on it as well. What is wrong with student evaluations? Oh, did you already? It's the same response as the line beforehand. No, not volunteer bias, although there is a huge problem with that too. Also, a lot of professors will bribe their students with donuts and stuff like that without letting anyone else know, or complimenting them just for and making it easy exam but just for. There's a bunch of ways you can game it, but Kara is what I was looking for in there. No, no, that's no, I didn't read that wrong. It was, you did say volunteer bias. Rami's earlier comment is actually related to it, but it's not exactly the same. I thought I saw it in here. Maybe I didn't. You do have volunteer bias, but what are you writing it on? You're writing it on a scale of 1 to 5, right? How good is this person? Scale is completely arbitrary. By the way, it's also not standardized at all. It's a big source of complaints for me, right? Is your professor on time weights the same as is he or she effective as an instructor? But besides that, right? Uh, some can't be quantified. In fact, they're trying to make it quantified, but a Likert scale is is ordinal data. The difference between a 4 and a 5, what is it? So my wife just drive me when she was a student. If this professor, she had no strong opinion about the professor, and you should not do this, by the way, she just go 3 straight down the middle. I don't know anything about this professor. 3 straight down the middle. Unfortunately, just like you guys and high school and the like, we have some pretty wicked grade inflation as well. And so a 3 is actually a crappy score for a professor, despite the fact that some people might think of it as average professor. It's actually considered like need a whole lot of improvement, right? Because most of the professors are getting like 4s and 5s. But what is a 4 or what is a 5? I don't know. You don't know. When you're grading this thing, you don't know what the standardized score is. There's no calibration, no nothing. You just know a 3 is lower than a 4. The person interpreting it is a 3 is lower than a 4. You have no idea what a 4 is. It's not quantified. It's ordinal data. A large t-shirt is larger than a medium t-shirt, but that's all you know. You do not know how big it actually is. And so you can't actually do standard deviations, averages, all these kinds of stats that they do on our student evaluations. They will say your average student evaluation is a 4.2 or something like that. What's a 4.2? You can't average it. It's ordinal data. You can't even represent it on a bar chart, stuff like that. It's ordinal data. You can't do average and standard deviations. The data doesn't work for the stats. And so you have not only this, you can't really properly quantify it, but if you try, it just means what your version or your interpretation of what that question means is different than somebody else's interpretation, and you can't actually do stats on it, but we do it anyways. Anyways, it's a pet peeve of mine. Um, so here's what we were talking about earlier with here's work, right? We talked about some channels are better than others. It turns out you can quantify this, in fact. So if I have ordinal attributes, position is the best thing you can do with it. Position on a line scale is not as good. Length of size, not great. Tilt, angle, all this kind of stuff. It gets worse as I go down. So the most effective versus the least effective. Notice where color saturation is. It's down here. It's still okay. Notice hue is not anywhere on this thing because it's terrible at ordinal data. Ordinal data, especially and continuous data, is even more extreme than this. These they work for both for ordinal and continuous data, or I always want to say continuous, quantitative data. They both work in this thing, but it's more extreme when it comes to quantitative data for this. But if you look at categorical data, spatial region is extremely important. Not even on the list here. Hue is extremely useful. Not even on the list here. It's terrible for over here. Motion is really good at figuring out if you're in a category of data. And the shape is great for a category of data. It's not even on the list over here. This is why maps look the way that they do. Satisfaction and reliability, but HCI people really should know about that, by the way. So anyways, if you're talking about a map, the reason you use hue is because it's good for categories of data. It is terrible for ordinal data. It's terrible for quantitative data. And yet we use rainbow color maps for or for some of our data sets, and it's a bad choice because we don't see it that way. So We will break down color perception later on, but there is a mapping between what channel you have and what attribute you can do. Part of your figuring out what the channel is, you figure out the attribute, and you have to figure out what kind of data you're dealing with. Is it one of these 4 types? Once you do that, now you can figure out what you really want to emphasize and what kind of data you have. That's why I wanted to put it immediately after talking about marks and channels. Okay, so this, by the way, Jock McKinley, 1986. Uh, for quantitative data, position is still fantastic. Texture is terrible. Connection is terrible. Doesn't tell you anything, right? Hue and saturation is shape is terrible for quantitative data. So I don't represent the largest thing with a triangle and the smallest thing with a circle. Makes no sense. People won't interpret it right. Okay. Here's ordinal data. Notice shape is still terrible. Position is still the best, but density is pretty good for ordinal data because you don't actually count. You just see like there's a lot. And density is way the heck down here for quantitative data if you actually want to measure the actual value. Here's nominal data, categorical data. Another term for categorical data. Position is still key, but color hue goes from fantastic to meh to holy crap, that's terrible. Choosing the right data set changes how you interpret the data. But position is still the best thing that we have in all cases. It's also the thing that gets thrown away with a pie chart. One of the reasons. So here would be an example of if you wanted an illustrative example of where things go wrong. So here is a continuous set of data. Here is I guess that is a discrete data. They're both quantitative, but Monday, Tuesday, Wednesday they are. It's you could consider it ordinal, but I'm not sure if I want to consider it ordinal. But they tried to do different sizes of these dots for quantitative data. They're calling this ordinal at least because, although I'm not sure I would, but small, medium, large for ordinal data, and for something that is categorical. The difference between an eagle, a jay, and a hawk is there's no real ordering here. And it turns out when you increase the size, it throws people off. They think that jay is better than a hawk. It's not. That Monday is better than Wednesday, let's say. It's not. There's some ordering effect. And it will throw, and that's the kind of thing that they were doing for the experiment. If I have area, area, and area. If I want to say the area, I want to use it for quantitative data. I don't want to use it for anything else. If I want to use color hue, I certainly don't want it for quantitative data. I want to use it for categorical data. If I'm using color saturation, where's color saturation? I want to use it for ordinal data. And just look up the chart and figure out what type of mapping I can use. So I don't think we have time for this exercise, so we'll pick this up again next time. But I wanted to point this out. And then, by the way, right immediately after this, we're going to take a little break. I'm going to eat something, and then we're going to start the interviews at 10:05. And I'm just going to go onto your Zoom links, 15 minutes. If I'm a little late, I apologize. I might be delayed by the other groups, but I'm going to try to keep to 15-minute intervals where you interview me about what you're exploring, and you're going to find out information from me. We're going to just conduct interviews, okay? And that's going to be for part of P3. That's all we're doing for the lab period. Okay. So I just wanted to point out what this thing is actually going to look like. How can we rearrange this? How can we fix this? How could we critique what's wrong, what's right about this sort of thing, and why is it so crappy? Because it's crappy. I had to find a real stinker out there. So when we come back next time, we will actually look at what are we looking at? I think it's human, perceptual factors the next time around. And then we'll get right into visualizations after we look at human cognition, visual perception, what other things? Object recognition, cognition, just in general cognition. We'll look at some optical illusions as well. So it'll be fun. But when we come back for the labs, you're going to just interview me and I'm going to try my best. Right. Thanks. I'll see you every one of the groups very, very soon. Thanks.